The next Fourier example I'm going to do is fx equal to 1 from minus pi to 0, so that's that, and fx equals 0 from 0 to pi, like this. So what we have here is a repeating square wave. Down, up again, down, and that's the final. Now, I overlap the function with sine and cosines. And what you should note is the green, once again, is our cosine, the red is our sine. When sine is down, our function is up. When sine is up, our function is down. So it has that plus minus thing, that's the same. So it's up, down. So probably this will most likely come from a sine function, but there's a bit more to it. So we'll solve this for the Fourier series. Once again, our Fourier series is fx equal to a0 divided by 2 plus some summation of cosines and sine waves times constants. And we have to calculate constants. The formula for a naught is 1 over pi minus pi to pi of fx. Now, our function is divided into two parts, so we can divide our integral into two parts. Very straightforward. So we have an integral that's 1 from minus pi to 0 and 0 to from 0 to pi. And that's exactly what I've rewritten here. Integrating this, what I have is 1 over pi x from minus pi to 0 plus 0. And that's equal to 0 minus pi all divided by pi, so that's equal to 1. Yep. So that's our first component. an is equal to 1 over pi integral from minus pi to 0 of cos nx times 1 dx plus 1 over pi 0 to pi 0 times cos nx dx. So immediately we can just get rid of that part. So we integrate this. That is equal to 1 over pi sine nx divided by n from minus pi to 0. And so that's equal to 1 over pi bracket sine n times 0 divided by n minus the sine of minus n pi divided by n. That is equal to 0 and that is equal to 0. So overall an is equal to 0. But that's no surprise because an is to do with cosines, and if we see in our picture, our cosine doesn't mimic the function we're interested in. So now we do bn. bn is equal to the integral from minus pi to 0 of 1 times sine nx plus the integral from 0 to pi of 0 times sine nx dx 1 over pi. Once again, that's 0, so we don't worry about it. And we just integrate this. That's 1 over pi minus cos nx divided by n from minus pi to 0. And so that's equal to 1 over pi minus cos n0 divided by 0 minus minus, which is plus cos minus pi n divided by n. And this is equal to 1 over pi. The cos of 0 is 1, so that's minus 1 divided by n. And the cos of minus pi n, which is the same as cos of pi n, is plus minus 1 n squared divided by n. So that can be rewritten as 1 over pi times n minus 1 to the power n minus 1. And so that is our power for different frequencies. So when n is equal to 1, we have 2 divided by pi, and so forth and so forth. And so our answer here is a half plus, that's our an and our sine wave. And so here we see the different frequencies as we go through them.